Welcome to the Joy of Coding. Hello, and welcome to episode 361 of the Joy of Coding. My name is Mike Conley. It's so good to have you here. We're going to be live hacking on some Firefox stuff today. It's going to be great. I'm very excited to have you here. Thanks for being here. Let's get started. I'll start by sharing my screen so you can see the agenda and what I'm looking at right now. Hey, it's April 3rd, 2024, episode 361. A reminder, no plan survives breakfast. I think I know how today's going to go. I think I know what I'm going to work on, but I don't know how it's going to go. I haven't done any preparation in advance for this stream. I haven't, checked to make sure that what we're going to work on is going to work out. I'm coding without a net. I'm coding on the internet, but without a safety net. Yeah, so that's the story. That's the name of the game. A thing you should know is that the agenda that we're looking at is something that you have access to. If you're watching this on YouTube or Dio.zone, check out the video description for a link. If you're watching this on Twitch, it's down in the video, or channel details rather, channel information. And if you're watching this on Air Mozilla, it's over in the details section over there. And as I update this little spinny will spin, and you'll be able to click on the links in the agenda copy, and that'll hopefully be useful. As I flesh this out, as things develop. And what I wanted to start with was actually talking a little bit, because I have a build going on in the background, unfortunately. It's almost done. I did not expect it to take 99 minutes. It turns out one of the things I've failed to do, and I just sort of figured it out, is my Windows Defender settings were properly exempting my source directory from, anti-malware scans. But the Mozilla build directory, which is what hosts like Clang or a lot of the bash tools, a lot of that was not exempt. And I've exempted both the Moz build and the Mozilla build directories in my home directory. But I only did that a few minutes before the stream started. So I'm hoping we're going to see an increase in performance of build time. Right now I'm doing it's a little disappointing. I am seeing the anti-malware service executable. Still doing a lot of work. I don't know why, but I'm hoping that'll eventually peter out once, once the sort of the exemptions that I've added kick in. I don't know what it takes for those exemptions to kick in. It's possible that I have to restart the machine, but or maybe restart some of the processes. I don't know. Maybe I just need to restart the shell here, and that'll be enough for it. But long story short. Hopefully that'll result in faster builds, and we're almost done this build anyways. I could have sworn that I had set things up that way to begin with, but either Windows reverted it or I'm misremembering. I don't exactly remember, but those exemptions I've just re-added. And that information for people who are on Windows builds, that information is in our Firefox build Windows. That's in our source docs. The Mozilla the Bootstrap tool is supposed to actually do it for you. However, if you've already got builds going, you might just need to do it manually. I don't know, but this is the instruction that I followed right here, to follow some manual steps and how to exempt the right folders and whatnot, and then that's what I did. So hopefully that'll cause my builds to be a little bit faster in the future. And now, while that's building, I thought we'd briefly talk about something that's related to the work that we've been doing for the past little while. We did mostly in 2023, and tangentially related to the things that we've been working on over the past couple episodes, which is the Windows jump list. I got CC'd on a bug. This is what it looks like whenever a crash report comes in. So I want to be very clear, because I feel like some people use the term crash very loosely. What I mean by a crash report, and a crash in particular, is, hold on, my background is, I'm just going to adjust that. There we go. A crash is whenever a process ends unexpectedly. Maybe it failed an assertion and is crashing itself intentionally. Or maybe it does something illegal in the eyes of the operating system, like trying to access memory it's not supposed to have access to, and that will cause it to crash. That's a crash, and you'll know it's a crash because either in the tab crash case you'll see like a little, oh gosh, geez, your tab crashed, kind of a dialogue in the middle. Or if it's a parent process crash that brings down the whole browser, you'll see a separate dialogue show up saying that Firefox crashed, please submit a crash report. And those crash reports are very handy because when a crash occurs, we have an opportunity to gather some information about the crash. And then if you like submit the crash report, it goes onto this, it goes through this ingestion pipeline. I think the ingestion pipeline is called Socorro. And then we have a tool for sort of browsing through some of the crash information on a site called CrashStats. So let me open this up, CrashStats. This is the crash report. Like, and then when a new crash shows up in CrashStats, our sheriffs, or in this case, I think it was Diana Smith, who's one of our. I don't know if Diana is a sheriff or like a release manager, but someone named Diana saw this crash report and was like, "Hey, this looks like a new crash. Here's the reason. Here's an instance of the report. Here are some of the top frames of the crashing thread." That's very handy if it's accurate. Here's the thing to know about crashes is that as soon as you have a crash, what happens is sometimes the memory is corrupted, and that can include the memory that has information about the stack. So sometimes the stacks are not reliable. If the process, the crash report can be very confused if memory was very confused. But in this case, we have a stack that actually looks fairly reasonable. You've got some thread that's running some method, and hey, some of these look familiar. Jump list builder, do set app ID, set app ID. So we're crashing here in jump list builder on line 76. So that's a really, really handy stack. And then what do you do about it? Like, why are we crashing? And so I did a little bit of analysis. So like that's all I had to work with. And if you go into CrashStats, and you can do this yourself, if you follow this link here, let me put a link in the agenda here for the bug and for the crash report. You can check it out yourself. These are public, and you can see all the information that got gathered during the crash. You know, like hey, this is a startup crash. The browser was only up for 4 seconds, and this was on version 124.0.1. And even though, I mean, it says not a startup crash, but it's pretty quick after start. So it's almost a startup crash. And here's the stack of the crashing thread. This is the stack. And, you know, you can see the other threads if you're interested on what the main thread was doing at the time. And in this case, it looks like the main thread was trying to, like, parse some URL or something and was allocating memory. But the jump list thread, it hit here. And so if like we can follow the actual line of code that the crash occurred on, is like that information is encoded in the crash report, and the version of the binary is also encoded. So we're able to actually pull out from our source control the line of code, the actual line of code that the crash occurred on. And we'll pull that up here. We can take a look. Sometimes Mercurial's the web UI is a little slow, especially if you're pulling up ancient history. Just give it a brief second here. Meanwhile, how's our build doing? All right, we're at the very end of our build. It's in mostly alphabetical order, so we're in the W's. That's good. Come on, hg.mozilla.org. This will be a lot. So one thing you may or may not know is that we're beginning a slow but steady transition away from Mercurial for Firefox desktop development to Git, and that means migration away from hg.mozilla.org and hgweb. And so hopefully in the future, when we're using whatever it is that we're going to be using for Git, I think it might be GitHub, I don't know, but this will hopefully be faster. So this is where things went wrong. We crashed right here, and the crash, if we look at the reason again, it was a exception access violation read. And that basically means, hey, you tried to access memory that you shouldn't. You know, is there a precise definition? Let's see. Exception meaning. Is there a meaning? Was there a precise meaning? I think the precise meaning is, hey, you tried to dereference a null pointer. And if you've ever written some C or native code or C++ or something, dereferencing a null pointer is a surefire way of, of crashing. And so the null pointer is almost certainly M Windows dest list, because that's what we're attempting to do. Like, set a PSZ app ID is a string like that we've been passed, and there is an assertion here that ensures that M Windows dest list exists, but Moz asserts really only do things on debug builds. And this user who submitted this crash report was not on a debug build. They were on a normal build. So, like, we go past these assertions, and then this dereference will occur. So what that means is nowhere in our CI did we ever detect this particular case. And that's kind of unfortunate. And I did a little bit of digging into, like, how could M Windows dest list be null? Because when we call set app ID, if you recall, I don't know if anyone here recalls when that occurs, that's in response to do set app ID, and do set app ID happens immediately after dispatching a runnable to set up the backend, and setting up the backend is supposed to construct a native jump list backend, and if you construct a native jump list backend, that is supposed to, inside the special lambda, set M Windows dest list. But what I failed to account for is that sometimes this can fail. Sometimes creating an instance of this custom destination list will fail. Like, there's sometimes error codes come back from this is calling into Windows and saying, hey, make me one of these things. And in this case, we fail, and because we fail, M Windows dest list remains null. It stays being null. And then the subsequent call to set the app ID will explode right here. And so that was my hypothesis, was, we are we're not handling an error correctly. So let's go back to the bug, and you can see the commentary where I had this discussion with one of my colleagues, Dave Parks, aka Handyman. So I do a little bit of a breakdown here, like, hey, here's it's my assumption is that Windows dest list is null pointer, Windows dest list is set here, so runnables should execute in order. So my guess is that we exit early and never set Windows dest list if we fall into this particular branch. In which case we should probably try to, like, in the event that we fail to create a dest list, we shouldn't try and do anything else. Like, basically the operating system is telling us, like, I can't allow you to manipulate the jump list. Because the thing that they give us to allow us to do that, they won't give it to us. So at that point, I think we should probably just give up rather than pretending that everything's fine and then explode. And so what I did was I wrote a patch. And let's take a quick look at the patch. And it wasn't like a one-shotter. There was a little bit of a conversation between myself and Handyman. But basically, the patch changed the name of the method from setAppID to doSetAppID if available. Because normally there is already a jumplistbuilder.idl. There's already a method called isAvailable that we call actually from the module lists. We call it here, and if either of the builders are unavailable, or like the jump list builders say that they're not available, then we bail out here, and that's good. That's the expected thing to do. But the actual constructor was also assuming that the builder would get the underlying backend would get created, and that's where we were falling over. Is the constructor would dispatch a runnable that just presumed that everything would go right, and not doing this isAvailable check. So that was where we fouled it up a little bit. And so we updated the method to be doSetAppID if available, and we just add this check: if the jump list is available. If it exists, then we'll go ahead and set the app ID. Otherwise, don't do anything. Just throw it away. And, you know, the later check to see if we're available by the front end will be used to, like, ensure we don't try and, you know, press buttons even though the thing's not available. And the other thing we needed to do, this was something that Handyman noticed. He suspected that the reason we're seeing this is because of a small set of users may have set this pref. This is a pref that is not, like, I don't think it's exposed anywhere. I don't know much about it. I think this was added, when was this added? This was added back in 2011. And what it lets you do is it allows people, in theory, to run separate instances of Firefox and have them individually pinned to the taskbar. And so, like, if you have different user profiles, they will exist as different applications in your taskbar. And I don't know if we ever ended up, like, really exposing that in the UI or anything. Let's actually take a quick look. Let's take a quick look at what landed for this. Mozilla Central. This is long before Fabricator, so let me see if I can find Com Central push. Okay, here are the patches that landed for Mozilla Central. Again, this is digging way into the past, so Mercurial is going to struggle with it a little bit. Add city hash and sys extension to other licenses. So we added some kind of like hash library. Okay, something called city hash. We added the extension, this nsys extension. We added the ability to use that to generate hashes to generate the app IDs, basically. So when you construct an application, when you are adding an entry to the taskbar with Windows, you have to supply like an ID, and every application that has, I think, the same ID, I don't know if they have the same executable name, but at least the same ID will be grouped together inside of the taskbar. And I think what's going on is, Jim was making it so that we can hash the profile directory into some string and then append that to the app ID so that Windows will treat them separately. And then there's like the ability to, well, hang on, where is this ultimately? Where is this exposed? So it looks like before we were just like statically generating the app ID, and now we're like dynamically registering it or dynamically setting it, which is good. Where I was expecting to see. This is a lot of NSYS stuff. Where's the... Maybe that was later on. Widget changes, installer changes. Maybe I should look at widget changes. Get app user model ID. Okay, so the default... So we like generate a unique app ID, and I guess we use some hash to do that or something. Blah 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 blah. But I'm looking for where the pref got introduced. Where's the pref? Profile option. That sounds right. So it looks like we never really exposed it. Like we made it so that people could set that pref, but we didn't really like expose it in the UI as a thing that you could turn on. It was just like, hey, here's a hidden pref. And maybe there was like there was a goal down the line to expose it in the UI. I don't know. I don't know anything about it. But all I know is that some people had it set. And I suspect that's actually where things were going wrong. Like in my conversation with Handyman, he was like, oh, that's probably where things are happening, because looking at the crash report, what was the conversation? He's like, there are these two calls to create jump list builder, and that all the crashes unsurprisingly have two jump list threads, and The non-crash thread is in the jumpless comm routines, preparing something for Windows error reporting, suggesting some trouble, creating an iCustom destination list. The calls seem to operate on different comm objects, but because of the different app user model IDs, unless that pref is set. And if the pref is set, in the event, so we've got newer code that tries to like group based on whether or not your application, your Firefox is in private browsing or not. And we weren't differentiating between private browsing and not private browsing. So if you have this preference set, this hidden preference set, and if you happened to like open a private browsing window, I suspect you might have a hard time here. Like creating the iCustom destination list would fail. That's what the Handyman was suggesting anyways, because you'd have the same app ID being used at the same time, or quickly soon after one another, and Windows is probably falling over. I don't know why. Like Windows is a little bit mysterious. They have documentation. You do a bow, you make some request to an API, and then you get a result back. And in this case, it's the suspicion is that we are violating some requirement where these app user model IDs need to be unique, and especially you can't request the same one at the same time from two different applications. Otherwise, you'll get like a null or a bad H result. And then we were handling that bad H result incorrectly. And so this is a little bit of belt and suspenders, where we try and handle the case where the jumpless backend isn't available correctly, and we're going to try and do the right thing with grouping applications for users that happen to have this preference set. So that was the fix. And if you take a look at the crash reports again, let me pull up the crash reports. Now, hopefully, this patch, if you take a look at the sort of progression here, the fix went out. It got pushed to Autoland 7 days ago, and then it landed in Nightly on March 28th. That's just 6 days ago. And then I requested uplift to both beta and release. So that's where all this conversation is coming in. I'm saying like, hey, this is a small fix that can help with stability. It's a simple enough patch. There's low risk. It's probably worth to uplift. So it got landed in beta. It got landed in release 4 days ago, and then we released a dot release. So there was already a dot release. Version 124 is what's on release right now, and we did a .0.1 release because of the Pwn to Own thing, which if you're not familiar, Pwn to Own is like a security conference, and like all of the web browsers, including Firefox, got people found vulnerabilities. We were prepared for that. We were always prepared for Pwn to Own. We knew it was coming. And as soon as we saw the exploit, we like deployed a fix, and we had one out within like I think less than 24 hours, which is stunning from like start to finish. From like hearing about the exploit to like rolling out a fix to everybody was less than 24 hours, and that went in 124.0.1. And then we knew we were probably going to do a .0.2 for other reasons. I think there were some stability things, and this got to ride along in 124.0.2, which went out, I think, yesterday. Firefox 124.0.2. This was released yesterday. So the fix actually went out. And if we take a look at the crash stats again, let's take a look at more reports. We can see all of the reports that have a similar signature. And we can take a look at all the reports here. And if we sort by version, well, first of all, someone's got to... This is an example of like, hey, it's possible that either someone is submitting garbage to us through the crash report API, or there was some memory corruption here, because that doesn't make any sense. Someone with a version 1024. But I don't see any 124.0.2s, which is really good. And there are only 49 results. This was not a frequent crash, just to be clear. This was not a frequent crash, but it was a thing that involved code that I had written, and so that's why I dove on it. And I think it's been fixed. Like the fix has only been out for a day, but we've rolled out 124.0.2 broadly, and so far no crashes have come up. So I'm hopeful that takes care of it, and I'll keep an eye on it. But that's the long and the short of it. I'm sorry to spend like 28 or so minutes on it, but basically that's the start, beginning, middle, and end of a crash investigation, patch, and fix. In case you were curious what that's like. All right. Well, now that I've stalled enough, hey, all right, we've got our builds, and it turns out that I've actually got both debug and opt builds. I had done my. If you take a look at this, I'd prepared to run my builds earlier in the day, and I was expecting them to be done by now. But the reason it took so long, along with the Defender stuff, was also because I was doing two builds: a debug build and then an opt build. So I haven't touched. That's not true. Since the last episode, and if you recall, what we had was a crash. We were dealing with a crash, and we had some notes here. Where is it? Where's this active bugs? Here we go. We had this crash, and why are we crashing when we attempt to get a favicon for a site we've never visited? And I said that the problem is that such and such takes runnable as an argument that runnable will only ever be called if we successfully retrieve and cache the favicon. And in any error condition, the runnable will not be called. Unfortunately, that will leave us with dangling promises. And so we spent some time trying to fix that by adding an optional argument to what is it? To cache icon from favicon URI async. Is that what we did? It was something like that. We decided we were going to add. It takes a runnable, and then it passes that along. We were going to pass this runnable. We pass the promise holder. Right. So we were going to optionally pass this promise holder around. That's what it was going to be. And in the event that we ever destructed, we were going to reject the promise. Whatever was owning the promise holder would, if destroyed before it can be resolved, like if the thing owning it was destroyed before it resolved in its like destructor, it would reject the promise. And we assumed that that would fix things, or I had assumed. And where like we pass it along here to async encode and write icon, and then we run here, and then if all went well, we would resolve. If everything worked out, we would resolve if exists, and if ever we destruct, we would reject here. And we assumed that that was going to work out. We built it, and it still crashed. And that was the cliffhanger. I'm going to investigate that crash today. And we're going to try and figure out what's gone wrong, what is wrong with our assumptions. And what else? There was something else I wanted to mention. We're going to investigate the crash. We're going to use the debugger to try and investigate it. Make sure that our assumptions are correct. I guess that's it. That's what we're going to do. We're going to use the debug build to do that. I've actually got both the opt and debug and opt builds ready. But let's run with our debug build, because we'll be able to more easily step through in that particular case, and we'll see where things fell over. Now, debug builds, as you are probably aware, are much slower than opt builds. So just give it a second to page everything into memory. There's a lot going on. Debug builds are intentionally non-optimized, so things take longer and they emit more debug information on purpose. So the browser is going to be a lot slower. Oh, I remember what I wanted to mention. The one thing I wanted to mention was I did touch the patch just before I started building, because I did a rebase. So this is up to date with the most recent Mozilla Central as of, I don't know, 4 or 5 hours ago. So that is a difference between the last episode and this episode. Like, a thing you didn't see was me rebasing the patch. And there wasn't anything special about that rebase. I didn't have to deconflict anything. It was a very clean rebase, but I rebased it. Okay, let us open up the toolbox and see if we can invoke some stuff and cause a crash. Now, what would be lovely is if there was some console history, but I got a feeling there isn't. Yeah. We might, if we're lucky, there'll be, here we go. We started to type some of this stuff up. So I can just paste this in. Okay, so I've got that part, and I want to get the I want to get a favicon for something I actually don't have. That's good. So I don't need to do anything too super special. But let me write this down in here. Test URI equals services.io new URI https example.com. Actually, that's not a good example. Let's do mikeconley.ca/blog. My blog. So put that in. That should be valid. Okay, and then we're going to get access to the builder. So Windows task jump list. Windows. What did I import? Win taskbar jump list. Win taskbar jump list builder. And confusingly, there is a thing called builder underneath it. And that's what we're going to call obtain and cache favicon async. We're going to pass our test URI to it. And this is what's going to crash. Now I'm going to, before I press enter, I'm going to paste this into here. And we're also going to await it, because this returns a promise. This should crash. Notice I'm not attaching the debugger just yet. Well, you know what? I should, before I do anything, let's attach the debugger. So the first thing I need to do is get the process ID 19208. So let's attach to that. Okay, let us now crash. Am I stuck at a breakpoint? What's going on here? It's running, so what's the... There we go. Okay, we crashed. And we crash here in Moz promise holder base. And this is the stack. Assertion failure, that there is no M promise. And promise holder base in default delete when the... Let's actually go into the source code. So we moved things over. And so we, because it's a unique pointer, holder, we made a unique pointer to hold onto the promise holder. I'm surprised that that's where we're failing. We are deleting on destruction because of I would have expected that by moving the promise holder, we would have moved the underlying promise. Is that not how it works? Standard move, promise holder. So it should work. It doesn't look like I have to do anything special to transfer the promise to. Holder ensure. Oh, there's the promise, and that's what sure promise, and I'm returning the promise. Let's go further up the stack. Maybe I'm releasing something because, oh, right, I'm up here. I'm up here. Notify icon observers that are being destroyed. Then the favicon data callback. Main thread pointer holder. Favicon data callback is being destroyed. The favicon data callback is being destroyed. Okay. Where do we have a favicon data callback in here? Equals this thing. And I've handed it the promise holder. I moved the promise holder to it. Wait a second, wait a second, wait a second. So async favicon data ready release. So I should actually be running. It should have been rejected. So I already did run the destructor. So it should have been rejected. And the Moz promised holder. When you reject something, reject if exists, we say resolve. If not empty, then we're going to reject. And what do you do if you reject? You're supposed to set the promise to be null. So that never occurred. That's very interesting. Why didn't we do this part? I think that's where I want to set a breakpoint. That's where I want to set a breakpoint for the next time this happens. Okay, so we're going to detach. We are going to rerun, and we're going to do that whole thing again. But this time we're going to have that breakpoint set. And we're going to see what happens at that destructor. Okay. Open up the console. Come on. There it is. And then we're going to go ahead and paste our, is back over here. We're going to go ahead and paste this stuff in. Also I'm gonna put this in. Services, app info, process ID. So with the process ID 17212. Let's make sure that we properly get our, our breakpoint has been set up correctly. And maybe we can add a couple of other breakpoints as well. Maybe we'll set one right here, just for giggles, And I keep going to the wrong place. We're gonna paste this line in here, and we're gonna hopefully hit our breakpoint so we can start stepping through. Okay, so we have our first breakpoint here. We got our promise is set here. All right, we're doing these things. We're creating the Moz promise. We create the promise holder. And then we're gonna call into these things. Step in, obtain and cache favicon. Step out of that. Here we go. Let's see if the thing happens. We're going to invoke async. We're going to check what's going on in here. We're going to check to see if the file exists, but we're doing it off of the main thread. It shouldn't exist, so we're going to fetch it. We're going to do this part, so we're going to break in here. Actually, I'm going to break here. Okay. Assert we're the main thread. We're going to construct. Oh. We construct. Return. We're going to construct our promise. Then we'll call this. Come on. No. No. What's going on here? Visual Studio is busy. No. Why are you busy? What are you doing? We're about to get into the really interesting stuff. Windows isn't busy. Visual Studio is taking up a lot of memory. It's thinking. I don't know what it's doing, but it's thinking. It's doing some... It's got a Node.js thing going. That's crazy. Come on. Where are you? Well, I'm going to give... This is very frustrating. I'm going to give... Visual Studio about 10 more seconds to get its act together before I kill it and start over. 10. Here, let's do a drum roll. Let's do a drum roll. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Sorry. All right. Well, this is hilarious. I'm gonna kill my dev tool here. Well, that was a bust. Let's try it again. You know what, this time I'm not gonna step through the whole thing. I'm just gonna go, I'm gonna set a breakpoint at the top of that destructor. That's the part I'm really interested in. I was kind of going through like stepping through the whole process as like, I was just kind of curious to see which way we'd go, but I actually think that destructor has the information that we desperately need. Okay, here we go. Paste this in. Process ID is 6088. Now, does it remember our breakpoints from last time? No, it doesn't. Thanks. So I guess I do need to, man. Mozilla, widget, favicon helper, put a breakpoint here. Can we go to the line of code? Okay, great. Now I'm actually going to disable. Where was the destructor I wanted? It was. I'm so mad. I think it was in a header. I think it was in favicon helpers. Where is it? Favicon helpers. Toolkit components places widget. No, can't possibly be. Was it WinUtils? .h, and then promise holder. It was one of these, so I'm going to set a breakpoint here. And is there another reject if exists? No. Okay, I think it was this one. So let's set a breakpoint there. Somehow we've already hit that breakpoint. I have a feeling it was for a subsequent call for the caching for like what exists in here, the privacy notice. Okay, so let's now do our thing where we call with a URI that we don't have a favicon for. Okay, just continue. Okay, so we are here. We are being destroyed. We're going to say, hey, whoa. Why didn't we run the thing? If promise holder. Oh. Promise holder, the contents of it, of the unique pointer are null. What? Did it get moved out already? Is that what happened? Call stack. The async favicon data ready. All right, I'm going to go ahead and continue and let us crash. The async favicon data ready. We move the promise holder into it. I want to see whether or not promise holder. We move the promise holder from a promise holder into it. I want a breakpoint here on favicon data not available, because I think that's the operative part. That's the part that I think we are going to hit. Very curious about why all of this is if def out. Oh, well, Moz Places does exist here, Visual Studio, so I don't know why this is all if def or grayed out, but okay. Favicon not available. And then on complete, I want a breakpoint there. And I want a breakpoint here. So we're going to do it again. Same business. Maybe we're just not being careful about how we move things around. Testing, since it's a unique pointer, it's not sufficient, I guess, to see that a unique pointer exists. You have to see if it's pointing at something. And in this case, I guess we're bailing out because we're not doing the thing in the destructor, because the unique pointer, the promise holder it's supposed to have been moved. To 6908. Nope. Go ahead and attach our breakpoints. All is well. All right, now do the thing. Okay. Continue. Okay. So here, M promise holder is what? It's optimized away. Okay, well, let me set breakpoints in each of these methods. Let's also go up one. A promise holder is a tuple. Is currently null. So presumably we have moved it. We have thus moved it. And it's actually an A promise holder, which has then been moved into M promise holder. Right? A promise holder. It's already been moved, right? All right, let's continue. Okay. This M promise holder is a tuple. It's null. We didn't get anything. We got... The promise holder wasn't successfully moved to us, I guess. It's null. The promise is null. So that's the problem, I guess. Is we have the async favicon data ready thing, and it doesn't it hasn't had a chance to move it because the thing doesn't exist. So when we're doing it wrong, it seems like when we construct this async favicon data ready thing, we are not passing the promise holder correctly. Contain and cat async favicon data ready. Async favicon data ready. We construct it right here. There's no other place. It's just the one place that we construct it. And we pass it a promise holder. And we do that by calling this. This is the case where we're using the old sync mechanism. This is the case where we do it from our current test. And oh. Hold up. Did I do this? Did I do this wrong? Did I pass? So auto prom. It's supposed to be the favicon page URI, the ICO file, the thread, and then whether or not you're using the, like what folder you're supposed to be using. Bump. And then a runnable, and then the promise holder. We're not passing the promise holder. What we okay, that's the problem. That is the problem. This is the old code. We need to actually pass the promise holder here instead of null pointer. And we don't need to actually do anything here. We can just pass null pointer. Right? Is that correct? And then what you really want to do is you want to say, like, if this resolves or whatever happens to this promise, we want to actually chain it so that if it resolves, no, we don't need to do any of these things. We don't need to do any of these things. We move the holder. The holder passes it along to async favicon data ready. In any event where things go horribly wrong, in the destructor we'll reject the promise, but in the good case, we'll pass it along to encode and write, and then the promise holder is passed along here, and then we'll resolve if it exists with the icon path. That's correct. I think that's what we need to do. I think that's why things were going wrong, is we actually had a bunch of old code still in there that was using the old runnable mode that I'd forgotten to update. That was my bad. In all this convoluted C++, I had failed to update a chunk of code to not use the runnable, but instead pass null for the runnable and to pass in a promise holder. All right, let's see if this fixes the crash. If it does, we're in pretty good shape. At that point, it's time to clean up the patch. I don't know how we're going to do tests for this. We might need to write tests in JavaScript, like a Moki test. That'd probably be best. Let's see what's going on here. We're going to link zool.dll. So it turns out we've found the killer, and it turns out the killer was probably me. The whole time. That's the story of software development. Linking. Have I already made a joke about, like, Abraham linking? Okay, well, let me make a joke about Abraham linking. No, I got nothing. I don't have a joke. I'll work on it. All right, let's run. A divided binary cannot stand. I don't know. It's pretty low quality. Low quality joke on my part. Mike with a Windows WM and a VM in the basement. Clue, Mozilla Edition. Yeah. I mean, in all seriousness, sometimes as a software developer, that's what it feels like. It's a detective. Sometimes I think I've said this before. Sometimes I feel like a soccer coach. Sometimes I feel like a firefighter. Sometimes I feel like a member of the bomb squad. Sometimes I feel like a detective, like a crime scene investigator, a detective, or down in the CSI, like doing the science. Sometimes I feel like, like all of these things at different times of like the software development life cycle. All right, let's try the thing. Let's do the thing. I'm not going to attach a debugger this time. We're just going to roll. We're just going to see if this works. I'm not even going to get the OS process ID. Let's go. Are you ready? Drum roll. I think it's worth doing a drum roll. Amazing! It didn't crash, but we did get an NS error failure. And maybe that's okay. In the event that we cannot get the favicon, we'll just return NS error failure. Maybe that's fine. What do we do in that case? What do we currently do if we can't find the favicon? Obtain. Oh, whoops. In the event that it's not found, favicon. What? WinUtils. Obtain cached favicon file. So in the event that we can't find it, we return an NS error. And what does our what does our jumpless code do? Obtain cached favicon. If we got a success, we'll set cached icon path to be a icon file path. We'll return it. Otherwise, we'll just let it pass. We'll just set it to be the empty string, which is fine. So what we made it is possible to do is just have this be awaiting right here. Hey, that's great. That's great. We can actually do that now. So let's do that. Let's do it. So let's update the front end now to use our new method. And I'll actually use an opt build for this. I think I can take advantage of the opt build that's also been built. And we can wire this up to the front end. Build with default mock build. Let's go over to Windows jump lists. Obtain and cache favicon. Async. Await. Any other errors, however, will abort on. What were we doing before? We were ensure success. Cached icon file. If it doesn't exist, we'll return NS error not available, and then we'll try and go and get it. So this is a slightly different case where if the icon has been requested, it might also throw an exception if there was a problem fetching the favicon from the database and writing it to the disk. In either case is non-fatal. Fatal, so we ignore them here. Okay. Then this should work. We're already... Oh, well, hold on. We can't do that inside of rows.map. We're going to have to actually change how we do things here. We are inside of an async function, but inside of a map, you can't really do this. So we're going to say custom descriptions for let row of rows. And then we're going to say these things. Let URI equal those things. Icon path. And we're going to say custom descriptions dot push. There we go. All right, let's just make sure that JavaScript got built out. I think we're seeing the light at the end of the tunnel. Now, that's not to say that there isn't more to do. There's tests to write. There's a lot of cleanup to do. Like, what we've written is fairly convoluted and complicated. We might be able to get some advice from some of our native code experts on how I can simplify things even further. But I think we're very close to having something that's functional. So those favicons were and now I'm going to click on it. It's going to try and load it over here, isn't it? Yeah. Okay. So this is the problem with. Let me pull up history today. I think those items, like, this is old information. Deadly moral mushrooms. So let's actually load some websites. A bunch of websites. We got a bunch of favicons in the history database, and then we're going to go ahead and we're going to pull up. We're going to manually update the jump list. So we're going to do this. Jump list time. Windows win taskbar jump list builder update. Builder update? Maybe just update. Hey, check them out. Check them out. Take a look. It's in a book. We got some favicons. Why do we have favicons? So Put the phone away. That's a new one. Put the phone away. So why didn't we get this one? Why didn't we get this favicon? Maybe it wasn't loaded yet. Let's run it again. That's interesting. What about in history? Do we have it over here? We do. So how come, what's the deal? How come I can't get the favicon out for put the phone away? We can try and investigate that. We got a couple minutes. So let's say let Axios URL equals services down new URI, and then win taskbar jump list builder obtain a cache favicon async Axios URL. Okay, so there is a URL there. I mean, there's a thing. Oh, hang on. Did I? Where's the folder? See, obj default, profile default, jump list cache. Okay, so let's go into the folder, jump list cache. There it is. So how come not over here? But the other ones worked. All right, well, let's take a look inside of the debugger. And sometimes this happens. I have to like restart the debugger because it doesn't attach to the right process. Win taskbar jump list. Win jump lists. There we go. Obtain and cache favicon async. Here we go. Let's do it here. And we'll go back to our console. And we'll run that. Oh, hang on. Let's do the update part. Did we break? Hit our breakpoint? Yes. Okay, so we have all these rows. Let's take a look at the URI for this one. Let's add a watch point. Watch expression, row.get result by name URL. So that's resolving to eater.com. That's not the one we care about. So let's just tick our way through here. Get Pocket, Electric Literature, Atlas Obscura, Axios, phone. This is the one. So we can actually set a conditional breakpoint for next time. Row.get result by name URL equals, and then we're going to copy that. Get result by name URL equals that. Okay, and then we're going to try and get the icon path. And did we get an icon path? We did not. So what's the difference? The URI and then what was the one that we were testing with? Axios URL. https://www.axios.com. Blah, blah, blah. Phone while driving, paying fine. UTM source, Pocket new tab, NUS. That looks right. So what happened? Why did this one not work? URI.spec URI.equals. I mean, so here's what I'm going to do. I'm going to save, store as a global variable. Can't I? Come on. Win taskbar jump list dot mconley test equals URI. Perfect. Okay. Play. So now we'll go over here and we'll say win taskbar jump list dot mconley test equals Axios URL. True. They're the same. So what's the deal? How come one failed and the other one did not? Obtain and cache favicon async. How come that one gives me back something and this one does not? Let's step through it again. Obtain cache favicon async URI dot spec. And let's call this right now and see what happens. Like if that gives me back something. So then now what do I have? Icon path. Okay, we have a thing. So then what's the deal? Play. Still nothing. Is it possible that how do I turn this into file URI? Can I? Is that the right? Is that the right? Let path equal that. Path utils dot parent. Okay, so it knows how to parse that. Await IOUtils exists path. It knows that the file exists. So what the heck? You know, if edit condition. Add condition. All right. I'm gonna set a breakpoint here. And now let's do exists or the update again. Yep. Icon path, we get a thing. Yep. Continue. Custom descriptions. Unfold them. Put the phone away. Icon path. There's your icon path. How come that's no good? What is the form of this file? What are the differences? How do I look at the view? Can I hex? Hex? Edit. I want to view as hex code. Can I use Sublime Text as a hex editor? Sublime Text hex edit. Plugins. Hex viewer. How about just like an online hex editor? I don't mind that. Online hex edit. Sure, let's try this. So how do I open a file? Can I just drag a file in here? Yes, okay. Let's go over here. Let's drag another one in. This is the one that I would expect to work. also a PNG. They appear to be valid. Images. Whoa, that's interesting. Different sizes. Different sizes. Okay, not our problem. Not our problem. I have a feeling that's the issue. And I would suspect, even without our change, this is still a bug. That for sufficiently large icon files, Windows is just rejecting them. Can we verify that? Yes, we can. Yes, we can. Let's verify that. Let's write that down. So I think we can check these off. We seem to have an interesting bug where the favicon from, what is the site? Axios, something about phones. Put your phone away. Put the phone down. Put the phone down. Isn't showing up in the jump list. My hypothesis is that this is because the favicon is quite large, and that the jump list backend, the Win32 jump list backend, is just silently failing to present it because it's so large. Let's prove that. So let's at least show that our patch wasn't involved. So I'm going to shut everything down. Shut them all down, hurry! All right. Shut it down. And we're going to build, I'm going to amend. I am going to have to break this patch up into different chunks, but I'll do that maybe during the next episode. That'll be fun, and then we can post it for review. But I'm gonna go back a revision. So without the patch, we are going to build an opt build. We're going to show that the problem still exists. If the problem still exists, we didn't introduce it. We didn't start the fire. We may have noticed it, and we may have a potential solution. Now, while we're waiting for this build to take place, let's take a look at the code that tries to get the favicons, and maybe we could even write a patch to fix this particular bug. So, for example, we do this thing where we're saying is async encode and write, and we get like some sizes, we get some surfaces. It says Windows will resize appropriately for us. Create a 48 by 48 surface in the event that things are too small. What if it's otherwise? By using the input image surface's size, we may end up decoding to a different size than 16 by 16 or bigger for higher DPI. Windows apparently will resize appropriately for us. If we want to encode ourselves one day because we like our resizing better, we'd have to manually resize the image here and use get system metrics. We don't support resizing images asynchronously at the moment anyway, so getting the DPI where icon size won't help. What is this value? What are these values it's talking about? The system small width of an icon in pixels. Small icons typically appear in Windows captions in small icon view. What's the other one? Sys M icon CYS. The system small height of an icon. Okay. The width and the height. Okay. What are the values? Does it... I guess 32, 48, or... Well, that's interesting. So we're almost done building. We're just finishing the XPCOM. I'm hoping to show that the patch is not the one introducing the favicon problem on Axios, and then we can file a separate bug if that's the case, and then we can call it a day. And next stream, I'm going to break down the patch into some component parts. We can get them individually reviewed. We get that stuff landed. And we're even closer to having ourselves in a state where we can be completely off the main thread with the jump list, gang. Woo! All right, if this is not done building in 30 seconds, I might cap the stream early. Well, no, that's not fair. I really want to know. I want to know if ours is the patch. So is there anything useful I can do while we're waiting for this build to complete? I mean, this is doing inflating, drawing target for size. Why can't we do the same thing? Why can't we just like make everything 48 by 48? Correct. Maybe we should just always make it 48 by 48. For the jump list, it really shouldn't matter, right? If it's smaller or bigger. Well, it's surprising to me, because like there's an assumption here. And maybe that's something we can do while we're waiting. Oh, no, build's done. Okay, let's pull this up. I'm curious who wrote this, because I'd like to ask about this. Windows will resize appropriately for us. Who said that? Like, someone's being, like, I'm curious to know if they have proof or information we don't know. Or maybe that's a thing that Windows used to do but doesn't do anymore. Brian Bondi, no longer at Mozilla. But we can read into this a little bit. All right. Let's pull up our thing. And we're going to call update. Yeah, still not working. So our patch did not introduce the problem. So let's file a new bug. Jump list. Where am I going to put this? Bugzilla. Where are the other favicon? What was it? WinUtils. I think this is going to be under Win32 or widget. New bug. Widget Windows. Jump list favicons don't work for favicons larger that are, well, let's at least get a precise measurement. How big was that Axios favicon? It is 144 by 144. Steps to reproduce. On Windows, open up the browser console in on Windows, clear history in Firefox, clear history, and open up the browser console. Put the following into the browser console to repopulate the jump list. What's the... check that the jump list does not have any history items in it, since history was removed in step 1. Visit https://mozilla.org and youtube.com, and then rerun the script, the JS in the console, from step 2. Check the jump list and see that both Mozilla.org and YouTube.com visits appear with their fav icons. 6. Visit where is it? Axios. Phone. Put the phone away. Visit. Rerun the JS in the console from step 2. Control-Shift-J to open. Expected results. In the jump list, the Axios visit should have a fav icon from that site. Actual results. The Axios visit has the default fav icon instead of the Axios fav icon. This seems to be because the fav icon from the Axios website is 140 pixels by 140 pixels, and I think the Win32 API that we're passing we're doing the right thing and caching that fav icon. Put the following to repopulate. I forget, we have to do it twice. And then rerun, do this twice. I'm gonna rerun the JS console. Do this twice. Check the jump list. Should have their fav icon. Visit. Rerun the console. Stop. Twice. Seems to be the fav. We're doing the right thing. Caching the fav icon on the disk, and looking at the cache. The fav icon is 140 by 140. I suspect that Windows is choking on that for some reason. Maybe we're exceeding some internal limits that... well, let's see here. What is it that we're doing with the fav icon? We're... fav icon... Oh. Fav icon... obtaining cache fav icon, jump list builder, icon, description, custom descriptions, jump list shortcut description, custom descriptions, and do populate jump list. So we construct these things, begin list, obj array, we create an instance of a thing, we get a shell link from a description from the custom list. Fav icon. If the icon was passed, then we'll use set icon location. So let's look at the documentation. Microsoft Win32 set icon location. Set the path of the file containing the icon. What's the size? What the address of a buffer to contain the path of the file containing the icon. What is the size that it expects? Get icon location. I shall link set icon location, icon size. size, icon. An icon, small arrow, shell link has an icon, it's called shortcut. Dimensions, width, height, size, icon size. Jeez. Well, it's not telling us. Maybe we're seeing some internal limits that I don't see documented here or here. At any rate, it might be worthwhile to just hard code some static size. 48 seems to be what we do for smaller icons, and always scale to that. 48. Less than 48. 48 pixels. Or ask the system for the icon size it expects. Yeah. Or maybe better. Okay, 132. That's, I'm gonna say that's a defect. Filing, submit. Okay, and we can maybe think about trying to fix that ourselves. But we have some STR in here. And yeah, next week, maybe we can start cleaning up our patch a little bit, getting it ready for review. We've got async favicon fetching working off of the main thread. We can start doing some try builds. We can run a test. It's going to be great. It's going to be great. I'm looking forward to it. Hey, thanks so much for watching episode 361 of The Joy of Coding. I hope that was interesting. I hope you liked it. Let's see here. I think we should be on schedule to do an episode next week. So I'll see you on April 10th. What am I going to write in the agenda today? We got the crash fixed, and the thing seems to work. But we found a bug related to large favicons, we think. Pre-existing bug. Found a pre-existing bug. I'm assuming it's due to the size of the favicon. At any rate, we can maybe look into that next. I don't know. Hey, that's it. Thanks again for watching episode 361 of The Joy of Coding. Let me know what you thought. Let me put the link to the Rate This Episode form in the chat in case you're interested. It's also here in the agenda. You can click on that. Let me know what you thought. Rate This Episode form. I'll just drop it in the chat. Feel free to write stuff in there. I read everything that comes in. Let me know what you want more of, what less of. Maybe you have questions. Maybe you have suggestions. I'm happy to cover it. Yeah, that'd be great. Thanks again. See you next week. Take care, everybody. Hold on, let me change. Take care, everybody. Bye-bye. The joy of coding. See ya.